What is up, good people? This is section 2.6, solving systems of inequalities graphically. Remember, we were solving systems of equations, and there were actually three different kinds of equations that you could, three different kinds of methods you could use to solve those systems of equations. There's only one method I'm going to teach you today to solve a system of inequalities, and that's using graphing. And it's going to be very similar to just graphing inequalities. Let's remind ourselves what it looks like to graph an inequality. This is what it looks like. There's actually two different inequalities being graphed, one for each of the lines. What it looks like is you convert, if it gives you something like this, you convert the inequality to an equation and graph. How do you graph it? Equation, table, graph. So each one of these lines has a table associated with it. And of course, the table goes in your composition book. Then you have to draw these lines either solid or dotted, depending on the symbol. This is not new. We did this in chapter 1. This line right here is a solid line. This line right here is a dotted line. And then take test points to shade. So you can test 0, 0 often, but if you can't, then you choose any point that's not on the line, and you figure out which half of the plane you shade. This bottom half got shaded blue, both these parts right here, and this right half got shaded yellow. Blue plus yellow is green, as we all know at SEH. Blue and yellow is green. Boom, that's blue and gold day. So anyway, the part that gets shaded twice, the doubly shaded area, is down here. It got shaded both, like I shaded two half regions twice, and this region over here didn't get shaded at all. This region got shaded once, blue. This region over here got shaded once, yellow. But this region right here got shaded twice. And the double shaded area is the solution set. That's new. Steps 1, 2, and 3 are technically not new. We did them in chapter 1. But now, if we do it twice in the same graph, the double shaded area is the solution set. Let me show you what I mean. Boom. We've got x minus y is less than or equal to 2. And then that's the red inequality. The blue inequality is here. Each one of these, it has a table associated with it. I'm going to choose values. I'm going to choose 0 for x and 0 for y here, and then calculate the corresponding values by plugging them into the equations. Here, 0 minus y is equal to 2. And then if I multiply both sides by -1, we get y is equal to -2. If I choose y is equal to 0 here, you get x minus 0 is 2, and that means x is equal to 2. Great, so I can plot these 2 points on the graph and connect the lines with a solid line right here. You can see the red solid line is right here, and I've plotted 2, 0 and 0, -2 with a solid line because this is a less than or equal to symbol in the original. And then here in the blue table, very much the same thing. Choosing 0 for x, choosing 0 for y, back calculating to get the x and the y, the x-intercept, the y-intercept. And I'm going to draw this with a solid line because this symbol right here has a line underneath it, meaning indicating that the boundary line could be included as well. So boom, we got 2 solid lines, and now we got to figure out which side to shade. I'm going to use as my test point 0, 0. If you plug in 0, 0 into this red original inequality, it actually turns into 0 minus 0 is less than or equal to 2, which is a true statement. If it's a true statement, then that means 0, 0 is actually a solution to the red inequality, and all its neighbors as well. So you can see this, the top left-hand portion, this right here is all getting shaded red. This is red, and also the top portion is red as well. It's all on the same side as 0, 0, which is a solution. But if you take that same test point and plug it into the blue inequality, 0 plus, see, here's the blue inequality, 0 plus 2 times 0 is greater than or equal to 1. We actually find that no, it turns into a false statement. 0, 0 should not be shaded blue. The other portion should be. So you can see here's 0, 0, it doesn't get shaded blue, and neither do any of its neighbors on this side of the blue line. But this one is on the opposite side of the blue line, so we know that it is going to be shaded. And so is over here. This region down here gets shaded 0 times. This region over here gets shaded only once in red. This region gets shaded only once in blue, but the top region gets shaded twice. And so all of these points are in the solution set. And it's actually kind of really weird to try and represent those like interval notation or whatever. So basically, the best way to report your answer is just with this graph and say, look, here are all the points. Boom. Let's do the whole thing again, the whole process. All right. So maybe one thing I should have done first is clear the fraction. That might have made things a little bit easier. Whatever. Okay. So here, red equation. There's red inequality, blue inequality, and this is the red table. I'm just going to choose 0 for x and 0 for y, and back calculate to find the x and y intercepts. Although I will say it's kind of tricky to graph decimals. If you can ever avoid graphing decimals, way easier to graph integers. But here, it's okay. This is a thing you can type into alex.com. On the plot pointer, you can type in -1/3, and it will actually, if you just here's the thing, a studentship tip, if you type in -0.3 and round, it's going to give you, it's going to say the whole thing is wrong. And this is one thing I don't like about Alex, is that it's not going to give you any help in figuring out why the whole thing is wrong. It's just going to say wrong because you rounded. Better not to round when you type in the point. Better to type in -1/3, and that will register as correct, and only that if you're typing in this point and this point. You could also choose different x values and y values to find, but don't round. The big idea is don't round when you type into the plot pointer. Use a fraction. Turn the blue inequality into an equation, and there it is. You can see y is equal to all this, and I'm going to choose, often you choose 0, 1, 2 to find out points, but I'm going to choose 0, 4, and 8 just because I'd rather multiply -1/4 times these numbers to get numbers that are not fractions or decimals. They're integers here. So -1/4 times 0 is 0, -3 is this. And then -1/4 times 4 is -1. -3 gives you -4. -1/4 times 8 is -2. -3 is -5. So I can plot these points also on the graph. You can see there they are. You can't see the other one because I zoomed in a bit too much. But there are all the points, and they're graphed, and I can connect them with a solid line or a dotted line depending on the symbols. The red line gets a solid line because of this symbol, and the blue line gets a dotted line because it's this symbol. The boundary is actually not included. Like 0, -3 does not satisfy this inequality because -3 is not greater than -3. Okay, so we've got a dotted line, we've got a solid line, and then we've got to figure out whether or not these, where to shade. Notice you plug in, 0, 0 is not on either of these lines, so I can plug them 0, 0, 0 into both inequalities. When I plug it into the red inequality, we get 3 times 0 minus 2 times 0 is 0 is less than or equal to -1. Is 0 less than or equal to -1? No, it's not. So don't shade 0, 0 when it comes to red. You see, over here, 0, 0 is not shaded in red. So on this half of the red line, I shade the region that is not containing 0, 0. 0, 0 is not a solution, nor are any of its neighbors over here in this region. So I'm going to shade this, the upper region and the left region. They're both on this side of the red, so I'm going to shade them both in. And then 0, 0, ding! Yes, it actually does work for this inequality because 0 is greater than -3. So 0, 0 does get shaded, and so do all of its neighbors on the upper portion of the top half of the plane that gets divided into like two parts by this line right here. So this gets shaded by blue, and this is shaded by blue because it's on the same side of this line as 0, 0. Looking back at how all the shading, this got shaded 0 times, this quarter of the region, the lower part, and the right-hand part got shaded once in blue, and the red got shaded once. This over here got shaded once in red, but this quarter of the region over here, above the intersection right here, got shaded twice, both in red and blue, and so therefore that is the answer. These are all these points you can look at over here. They all simultaneously satisfy both of these inequalities. Word problems. Here we go. Knowns and unknowns. Make sure you put them in your competition book. Example number 3. Playas, this high school auditorium has 800 seats. That sounds like a total. Suppose that the drama club has a goal of making at least 3,400 each night. At least. So bare minimum $3,400. Maybe you could make 3,500. Yes, you could make 4,000. You could make $5,000. That would be at least make this goal. You can't make 3,000. You can't make 1,000 because that would not satisfy. That would not be at least your goal each night for the fall play. Student tickets are $4 and adult tickets are $7. Graph this as a system of inequalities and find a reasonable combination of student and adult tickets that would actually help them meet their goal. Okay, so let's make a graph. First step. Sorry, not first step. First step is to figure out your unknowns and your knowns. What don't we know? We don't know how many of each they're going to be selling. It's kind of tricky to figure out from the word problem, but we have student tickets and adult tickets. I don't know how many of each you're going to sell. We do know their cost. We don't know how many. So X is going to represent, for me, the number of student tickets, and Y will represent the number of adult tickets. Super important here. I enjoy choosing, if I know I'm going to be graphing it, I enjoy choosing X and Y as my letters from the alphabet. You don't have to. You can have axes that is like the A-axis and the B-axis when you're graphing. And in fact, that's one thing that the College Board does to make their SATs trickier, is they change up the letters of the axes. They make it difficult by choosing their unknowns A and B, or M and N, or whatever other letters not than X and Y. But if you want to make it easier for yourself, then you can choose X and Y, especially if you know you're graphing. But it's always good to write it out. Like, to make this choice, it might be like, wait, what was X and what was Y again? So write it out so you can clearly see which is which as you make your other equations. We got two totals. The total, so there were a total of 800 seats and a total of $3,400. But you don't actually have to sell all 800 seats. You could sell fewer than 800 seats. You max out the auditorium when you hit 800. That's the number of tickets you can sell. But you don't have to sell 800. You could sell 700 or 600 or 750 or 799 tickets. You can't sell 801 tickets. You can sell exactly 800. So that is represented with a less than or equal to symbol. Similarly, this 3,400 is our goal. People, if we can't raise at least $3,400, then we are going broke. Like, it's not worth it financially to do this play. So that's our goal, and we can hit more than that if we want. We also know that for X, it's $4. The price is $4 each, and the price for Y is $7 each. So with that, we can say there's a total amount of money of $3,400. That would be 4X plus 7Y. These are the costs times the number of tickets. And that's got to be greater than or equal to 3,400, because you have to make at least 3,400. It says at least. At least corresponds to this symbol right here. And then total number of seats, this is a simple X plus Y, is less than or equal to 800. Boom. Okay. Now that we have the inequalities, I think the hardest part of this might be just coming up with the inequalities and making sure you got the symbols in the right direction, and making sure you matched up the X's and the Y's with the numbers that you need, 4 and 7. But once you do that, then there's still we got a long way to go, but it's a bit more straightforward, because we can take both of these inequalities here and we can turn them into tables. So this is X and Y, and I've got this, the red inequality has a red equation. The boundary line for this inequality would be this equation, and then we can choose 0 for X and calculate the Y. Choose 0 for Y and calculate the X. And now these are points that we can graph on the graph. These are the X and Y intercepts. Similarly, you can choose for the blue inequality. It has this blue equation. That's where the boundary line would be. And you can choose 0 for X and calculate the Y, and choose 0 for Y and calculate the X. And you get the X and Y intercepts. Note, I've plotted them both right here. Here's the Y-intercept for blue, Y-intercept, X-intercept for blue, Y-intercept for red, Y-intercept for red. And now we got to figure out exactly how, exactly which region are we going to shade twice. Well, 0, 0, is on neither of these lines, so it's a perfect candidate for shading. You don't have to choose 0, 0, but I like it because it makes the calculations way simpler than otherwise. So you plug 0, 0 in, and you get 0 is greater than or equal to 3,400 in the red inequality. No, it's not. Don't shade 0, 0 in red. Shade the other half of the line. So this entire half right here on the red line divides the plane into two halves. One with 0, 0 that doesn't get shaded in, and the other side that does. This is red, this is red. It's on the other side of the line from 0, 0. Now plug 0, 0 into the blue inequality, and all of a sudden, yes, we get 0 is less than or equal to 8,000, and that is a true statement. So yes, 0, 0 does get shaded blue, and all the other neighbors on this half of the blue line. So here and here are both share the same half of the blue line. Notice after we finish both shadings, we get an empty. This tiny little region over here of our window, we didn't get shaded at all. This upper portion over here got shaded once in red, and this bottom portion of this here only got shaded once in blue. However, this slice right here got shaded twice. And if you can somehow sell tickets that are represented by these number of points, then you're going to satisfy both of your inequalities at the same time. Kind of hard to do. 400, 200 does not work because it's not in both. So let's see. We could sell 500 of the. You could, like, this is a point right here. 500y and 100x would work. 500y and 200x would also work. Even 500y and 300x would work. So any of these points right here would be solutions to the inequality, the system of inequalities. Whew, what a process. It's long. Let's do this again. Example 4, finance. Sheila plans to invest $2,000 or less in 2 different accounts. I'm going to stop right now and tell you that I got married. We can tell you what I got married. I got married at the Morris Arboretum, very close by to SEH. Fantastic, beautiful place. The Morris Arboretum was like just one place that we found. I didn't even live near Philadelphia at the time, but I happened to get married to a place where I happen to now have my job. How awesome is that? Funny coincidence. So audio check is Morris Arboretum. The low-risk account pays 3% annual simple interest, and the high-risk account pays 12% annual simple interest. This is a very common technique in investing. It's called diversifying your portfolio. You don't want to put your money all in low risk because you're not going to get a whole lot of money, and you don't want to put all of your money in high risk because you could lose it all. So if you have a nice even portfolio, some of this and some of that, then that's kind of like a medium solution between the two. You can still get a medium amount of money and absorb a medium amount of risk if things go bad. So diversifying your portfolio. That's what she's doing. She's got these 2 accounts, and we got percentages on each. She wants to make at least $150 in simple interest this year. Graph the system of inequalities, make a recommendation, because you're the financial analysis. If you want to make money in this world and you want like a high-paying analyst job, this is the kind of thing you've got to be able to analyze. There's not one solution. There are many solutions, and you can make a recommendation. In Alex, if you report any particular correct solution gets reported, then it will know the difference between them, and it will count it as correct. Graph the system and make a recommendation. So what are the unknowns? I'm going to choose X and Y because I know I'm going to be graphing them later on. So X is going to be low risk. Y is going to be high risk. And then the total. We got some totals here. Total of $2,000. Total of $150 of interest. So there it is. We want to make at least, our total. Okay, so $2,000 or less. She's only got $2,000. She could invest for less than that if she wanted to. If you wanted to make that recommendation, she doesn't have to spend all her money on these accounts, but she can spend max. She's budgeting $2,000 for this, no more. That's why we use the less than or equal to symbol. And then she's got a goal of $150 she wants to make at the very least. 200 would be nice. 500 would be great, but she's got a goal of 150, and you've got to at least hit that. So that's why you're using the greater than or equal to symbol, because the interest actually could be bigger than 150. That's your goal. We also know the percentages on each. The low risk is a 3% simple interest, and a 12% is going to be high risk. That's actually impossible to know in the stock market beforehand. You don't know how much each is going to get. You can make predictions and guesses, but stock market goes great, that could be higher, and stock market goes terrible, it could be lower. So, but for the purposes of doing a simplified version, we can make, just use these as predictions. Just go for it. So the red total would be 150, and then convert these percents to decimals and say, well, if you put this much money in and get 3% out, and this much money in and get 12% out, then you add them all up, and that we hope that's going to be at the very least 150. More than that would be great. X plus Y, that's how much money you're investing total. And it's got to be, you're only budgeting $2,000. You don't have to put all of the $2,000 into the stock market, but max, you got to put $2,000 in. Could be less. I'm going to clear the decimal, multiplying all the terms on both sides by 100. So that the 3% becomes 3, and the 12% becomes 12, and the 150 becomes 100, or 15,000. And then, boom. So now we've got to graph both of these. Both of these inequalities represent tables that you can actually make. Notice, plug in 0 for x, calculate the y. Plug in 0 for y, calculate the x. And then same for blue as well. Plug in 0 for x, calculate the y. Plug in 0 for y, calculate the x. And so these are x and y intercepts you can graph. And here they are. It looks very similar to the last one, maybe a bit more stretched and distorted. You have to zoom out quite a lot to hit these large numbers. But when you zoom, and that's another thing about the SATs and ACTs. Often when they give you these kinds of equations to graph, like if graphing is the one thing we want to test, they also want to test to make sure you know how to zoom. So they're going to give you something that, like, the standard region is right here, and you don't even see it. Like, where's all this stuff that I can graph? It's not even there. You can check it out and see that there it is. You have to zoom out to do it, and that's what they're testing. So you graph the intercepts, boom, and then you can see that there's even an intersection right here of 1,000 and 1,000. So, and how do we know which region to shade? Well, you can put 0, 0 back into the inequalities. 0, 0 into the blue does work, so 0, 0 gets shaded blue, and all of its neighbors on this half of the blue line. And then 0, 0 also works here. No, it doesn't work. So 0, 0 doesn't get shaded in red, and so therefore, on this, the red line divides this half of the plane into two halves. So the upper side that doesn't contain 0, 0 gets shaded. This is the part that gets shaded twice, and that's why. So you can't make a recommendation of negative numbers. So really, this small little triangle is your happy place where you can make recommendations from. You could recommend, for example, don't put any money in here for 0. Like X could be 0, and Y, you could make all your money in the high risk stuff, $2,000. Maybe that's not exactly diversifying your portfolio. So do some of each. Do 1,000 here and 1,000 there, and that will hit both goals. You won't max out the budget, and you should get $150 in interest if the predictions is right. I want you to tell me what number is here, and I got an Inspire for you. Check it out.